Hello, welcome everyone. So today we're going to do Maths Methods Exam 1 for 2021. Let's get to the work and see if we can do that as quickly as possible. So the very first question, which is has two parts in it and it's worth 3 marks, so that's pretty good. So let's start with part A, where we have to differentiate y to e to the power negative 3x with respect to x. So to find out the derivative dy over dx with respect to x, what we need to use is, we know the derivative of exponential is function itself. We apply the chain rule, so we get 2e to the power negative 3x, and then that will be multiplied by negative 3. So that gives us negative 6e to the power negative 3x. So that should be enough for you to get 1 mark for that. So now let's see, then we have to evaluate f dash of 4. What does that mean is, first we need to differentiate this function f dash of x. So product rule. So we do that x is 1, so root 2x plus 1. And we get x times 1/2 2x plus 1 to the power negative 1/2, and then the derivatives 2. Just simplify that a bit before you substitute x is equal to 4 into that. So we get x over 2x plus 1 square root. And then now I'm going to do f dash of 4. So that will be 8 plus 1 plus 4 over 8 plus 1, so which give us 9. Square root of 9 is 3 plus 4 over 3. That gives you 9 plus 4 over 3, give us 13 over 3. So this is our question number 1 done. So that's easy. Always spend less time on the things which are easy. Okay, now let's look at that question number 2, part A, which is 2 mark question. So we need to do f dash of x is given, which is x cubed plus x. We need to find f of x given that f of 1 is equal to 2. So the very first thing is, we need to realize that the derivative of the function is given. So we're going to do is do the reverse the process, means we need to anti-differentiate it, f dash of x dx, and then you do anti-differentiate on that other side as well to get the function itself back. So f of x would be equal to x4 over 4 plus x squared over 2 plus arbitrary constant. And then we can use this one here. So f of 1 is equal to 2. So you can sub in that f of 1 is equal to 2. That means when x is 1, y is 2. So that means you go 2 is equal to 1 over 4 plus 1 over 2 plus c. And then take everything on the other side. You get 2 minus 1 over 4 minus 1 over 2 give you 4. 8 minus 1 minus 2 to give you 5 over 4. So we got that arbitrary constant. So it means now we got f of x is equal to x4 over 4 plus x squared over 2 plus 5 over 4. Because arbitrary constant mean it could have many values there, but given this condition, f of 1 is equal to 2, we could evaluate that particular value of this constant. Okay, the next one we have is question number 3, which we need to tell now what is this function is is a trigonometric function. F of x is equal to 2 times sine 2x, and then we need to tell what is the range of the function. As you remember, the 2 at the front is amplitude, which gives us the range of the function. So according to that would be negative 2 to 2. And then we need to tell the period of this. Period is of the sine function. We know the formula is 2 pi over n. What is n? N is a coefficient of 2x, of x, which is 2. So 2 pi over 2, which gives you pi. And then we have to solve this 2 sine x for x is equal to r. So what does that mean is we need to find for all value of x equal to r. That means we need to get the general solution. So let's get into that. So we can write this one as sine 2x is equal to root 3 over 2. And now you know that sine root over 3 over 2 and sine is positive. You can quickly draw that special triangle if 2, 1, root 3. And you know that root 3 over 2 sine would give you pi on 3. So that's a pi on 3 is our angle. So that means we say 2x is equal to pi on 3. Because x is in all real number, we need to make sure that we consider where the sign is positive. So the sign is positive in the first quadrant and in the second quadrant. So that means the one value would be pi on 3, and the other value we get is 2x is equal to pi minus pi on 3, which would be 2 pi on 3. And then because it's going to be repeating itself, so we go 2 plus 2n pi plus 2n pi. So that's the generic solution. So that will give us x would be equal to pi over 6 plus n pi. And then this will give us pi over 3 plus n pi. And we also need to make sure that we tell n is an integer. So you could write it that n is in the integer. N is integer. So that will give us the equivalent, the general solution for this one, pi over 6 plus n pi, pi over 3 plus n pi. So that should be sufficient for this the question. So 3 marks. So let's look at the question number 4. We have sketched the graph on the x-axis, label the asymptote and intercept with their coordinates. So make sure we label everything. Solve. So we have this graph. So we see that this is a hyperbola function, which is being translated 2 unit to the right. So that's the asymptote. So you draw the asymptotes there first. So that's our asymptote. And then it's been shifted. The graph's been shifted 1 unit up. So 1 unit up. So there's the asymptote there. Okay. And then we have to look for what? And it's been reflected. So that means the graph is going to go into the second. Usually the hyperbola is in the first and the third. Now it's going to go into the second and the fourth quadrant. So we need to also make sure whatever y-intercept is when you sub in x is equal to 0 there. So you get a +1, and that means that's my y-intercept. So I have to be careful when I'm graphing it so that I don't mess up these intercepts. So x is equal to 2, and then also need to make sure what is my x-intercept. So you put in y is equal to 0 is equal to 1 minus 2 over x minus 2, and then you solve that for 2 over x minus 2. So then you get x minus 2 is equal to 2, x is equal to 4. So x is equal to 4 is my x-intercept. So then I will graph it. Okay, so we got the intercepts, right? And then we say label the asymptote. So this is x is equal to 2 and y is equal to 1 asymptotes. And the axis intercept, so we label them 4 and 2 with their coordinates. And then you can for a side note, you can also say x-intercepts is 4, 0, y-intercept is 0, 2, and that would be the sketch for it. And now we were looking for the x values when this is greater than or equal to 3. We need to solve that inequality. what we do for that one, we could just, what it means is when you have that x is greater than or equal to 3, we just need to find out that interval, when that interval would be. That's the thing. You can directly look at that, or you can solve that. So x is equal to y is greater than or equal to 3. So means we are looking for, if I just go back into the graph here, means that's the line we're looking for. And that if you graph this line, is a 1-mark question. So that's why I'm not really worried about solving the other way. I'm just looking at that. So I'm saying when this would be greater than or equal to 3, 1 minus 2x would be greater than or equal to 3. So which I can directly look at that, this interval, but greater than or equal to 3 is like this one there. Or I could solve it the other way around. So you could say that x is going to be 1, 2. Okay. And now we have our question number 5, which is, we're going to do is, we have two functions, f and g are given. The graph has f of x, f and g have the common horizontal axis intercept that's 2 is equal to 0. Find the coordinate of the other horizontal intercept of the graph of g. So that means we are saying is 4 times x minus 1 square minus 4 is equal to 0. Take the 4 on the other side. X minus 1 square is equal to 4 divided by 4, which gives you 1. So I'm saying x square minus 1, x minus 1 square is equal to plus minus 1. X minus 1 square is equal to plus minus 1. That could give me x is equal to negative 1 plus 1, or x is equal to negative 1 minus 1. This gives me x is equal to 0 or negative 2. I think I think I made a mistake here. Let me just rewrite it. So we got 2 values of the x. That's definitely be 2 values. We are saying is, that's what happened when we started to skip the step. X minus 1 is equal to 1. And I'm saying x minus 1 is equal to negative 1. So that gives me 0 and that gives me 2. So that means I've got 2 values. One is 0 and the other one is 2. So therefore, the x into 2, 0 is already given. So the other intercept is 0, 0. The x-intercept is 0, 0. Okay. And then we got B part of the question, which says, let the graph H be transformed and graph of F where the transformation have been applied, a dilation of half, vertical axis, translation of that, state the rule and coordinate of intercepts. Okay, so we need to first say the h is the transformation of the function. So we write h of function, h of x, which is equal to what? The function being dilation of factor a half from the vertical axis and translation by 2 units from the right. So that means that rule would becomes 2 times x minus 2 square square minus 4. So that would be our rule, which you could leave it like that, or you could simplify it. It's all completely up to you. You can simplify that one. And then we need to find the x horizontal x-axis intercepts. So that means you do the same thing, say 2x minus 2 square minus 4 is equal to 0. And then simplify that to x minus 2 square x minus 2 square is equal to 1/2, and not half, it's a 4 over 2, which gives you 2. And then we simplify that, x minus Okay, so that's the 2 square as well there. So 2 square there. So that means we got what we got before, right? So 4 times x minus 2 square minus 4 is equal to 0. So that means x is equal to 4, x minus 2 is equal to 4. So that gives us the intercepts. X minus 2 square is equal to 1. So that gives you x minus 2 is equal to 1. X minus 2 is equal to -1. So that gives you x is equal to 3 and x is equal to 1. So 3 and 1. So that means with the coordinates would be 3, 0, 1, 0. So these are the horizontal axis intercepts. Okay, so that's our question number 5. Now I think, and we'll do another video for the next question. Please keep watching to the next video for question number 6 to onward. And if you like this video, please share and subscribe. Thank you.